All right, what is going on, guys? Welcome to this episode of WuBlockchain podcast. I'm your host, Shang, and today I have Garrison from IONET. Hey, Garrison, thank you for joining. How are you today?
I'm doing great, Chang. Thanks for having me.
Likewise. So, for those of the audience who are familiar with IONET, can you just give a quick background and overview of what it is and how it came to the picture?
Yeah, of course. IO.net is building the largest AI compute DeepIn, and our goal is basically to build a decentralized AWS competitor. The project started in 2020 when our founder and CEO was actually creating quant models for algorithmic trading, and he was looking for better ways to source cheaper compute. Even in 2020, buying compute from AWS and Azure was extremely expensive. And so what he did was he was looking at sources of compute across the world in countries like Saudi Arabia and APAC, independent data centers and crypto miners that were being used. And he was networking them together, picking up GPUs from all of these different geo-distributed places and creating one gigantic network for compute. And it worked. He basically was looking at Ray, which back then was not necessarily really popular because most people use Kubernetes, right? Which was made popular by Amazon Web Services. And he ran the network himself for his own trading models for 2.5 years. In 2023, OpenAI launched and created ChatGPT, and the whole world started looking at AI, but the world also started looking at the amount of compute the AI was consuming. ChatGPT in 2023 announced that they were spending $700,000 a day to train their ChatGPT model. And people were also wondering how they could possibly serve inferences, right? Which is when you ask ChatGPT something, it gives you something back. It needs to inference the model. How could ChatGPT serve you real-time information that quickly and not charge you, right? And so what Ahmad realized is that OpenAI was also using Ray architecture to scale their own compute network. And that's how the business was born. Ahmad basically said, wait, I have something that the AI industry wants, right? I have the ability to scale up decentralized and distributed nodes, and I can provide compute for less cost to AI companies. And that's how IONET was born. So we actually were one of the winners of a Solana hackathon in April 2023. The platform officially launched to the public in November of 2023, and we're now just a little bit over 4 months, and things have been moving very quickly. The second piece of why we are building IO.net, right? In addition to trying to build the largest AI compute DeepIn, is that we want to make sure that there is some kind of decentralized, community-driven, and community-owned compute network in the world, in the same way where blockchain exists to have uncensorable money, in the same way that Ethereum exists to be like an uncensorable and accessible, globally usable world computer. Having some source of decentralized compute will ensure that dApps and other sources of data and AI models and AI model inferences remain globally accessible, uncensorable, and usable across borders in the future.
Got it. So for those of the audience who not so familiar with the AI and cloud compute industry, could you maybe like just dive a little bit deeper into what does the industry look like today? And again, like what are the pain points with centralized AI compute? And how does for say someone who wants to train their AI or wants to deploy an AI model would need some platform like IONET instead of a platform AWS, were there any other similar centralized platforms?
Yeah, that's a fantastic question. So AI has been around for actually quite a while, right? It's really consumer AI and also consumer visible enterprise AI, right? The AI that we see as consumers, that is a little bit newer. And ChatGPT really opened a lot of these doors, as well as generative AI image and video platforms, because these become tools that we can use in our everyday lives and immediately become helpful to us, right? But what most people don't know is that we've been using AI for a very long time, right? Facebook uses AI to scan images that you post. Google uses AI to help power their search engine. When you talk to Siri, right, there's a certain amount of AI that is used to recognize what you're saying into Siri and then returning an answer to you. And so AI has been a part of our lives for quite a while now. It's just more visible and it's in the news now. As AI become more popular and as more companies want to develop using AI, their costs increase. Compute is one of the most important and increasingly scarce resources or commodities in the world, right? You guys, everyone has seen Nvidia stock price and Supermicro stock price. And basically the story is they cannot produce hardware fast enough for people to consume, right? And today, AI uses GPU compute over CPU compute. And so these graphics cards, right? GPUs are graphics cards, are now in very, very high demand. The problem is that relative to the amount of compute that we need, we have significantly less, almost 2.5 times less compute that exists in centralized cloud providers. Centralized cloud providers are AWS, Azure, Google Cloud, right? They don't have enough GPU compute to serve everyone, even though these big companies are hoarding a lot of the graphics cards. Then when you look at the amount of compute that is available in the world, there's a lot of compute that sits in independent data centers. There's a lot of compute that sits in crypto miners. There's a lot of compute that sits in our consumer devices, our MacBook, our gaming PCs, all of this, right? Each one of these has some amount of capacity, and it's sort of like an efficient marketplace problem, is that usually there's a lot of resources that exist in the world. They're just very hard to aggregate. And so it's very hard to utilize that. What IO.net does is it aggregates the compute capacity across GPUs from different sources. Some are higher quality, some are more reliable, some are more valuable than others, but we aggregate it all. We provide that compute capacity in a cluster to deployers so that AI companies can access it. The result is that AI companies can access this compute for up to 90% cheaper compared to other on-demand prices from centralized cloud providers. And it's faster, right? With IO.net, you don't have to sign contracts, you don't have to KYC, there's no long-term commitments, and you get to choose where your nodes are from, what speed they are, etc.
So it sounds to me is like every latest tech, every top tech companies, they're looking after this like the newest chips from NVIDIA, right, to train their models. And actually, for like I'm just putting assumption, 100 4090s, this like retail graphic cards, probably like could be equivalent to a enterprise level H100 or any of those like highly sought after chips. And Ionet comes in, says, hey, we can put together this 100 4090s and provide this kind of equivalent compute power as a very hard to get enterprise level graphic card. Is that kind of the right assumption or the correct guess?
That's a fantastic question on the 4090s. The short answer is yes. Clustering together multiple, slightly less enterprise grade cards can give you the same amount of compute for a lower cost. The challenge is always scaling up that physical infrastructure, right? Which is what IO.net does. The second is we can also cluster together enterprise cards too. Independent data centers will sometimes have 5 cards here, 10 cards here, and multiple enterprise data centers are not going to talk to each other to serve one customer. But if they all put their capacity on IO.net, we can cluster it together and it maximizes right monetization and utilization for these enterprise grade DCs also.
Got it. So I guess the main differentiator is that since it is pretty much like free compute, right? If it since it's essentially free compute, then it is going to be a lot less cheaper compared to this like giant tech firms or giant clouds who are really putting their chips at work, right? Because if I have some 4090s, chances are I'm like less likely to expect a higher income out of those graphic cards. So that kind of create better economics for the demand side. And since you're making some of the money, and it's better for the supply side as well.
Yeah, I think the way to think about it is if we're tapping into a resource that would have been underutilized anyways, then we can pass through, right, that underutilized capacity to an end customer. And because that capacity was never going to be utilized optimally, then it's cheaper economically for the end customer. But I want to be very clear, right? While we want to build a decentralized alternative to centralized cloud providers, I don't expect it to fully replace the existing infrastructure, right? The best comparison is when you think about the power grid. A lot of people really like to talk about renewable energy, right? Solar and batteries as a way to manage the grid. And we all need to understand that we're not going to replace base level power generation like nuclear power, right? Nuclear power generates a lot of energy over time. It's very stable. It's very cheap. It's very efficient. But nuclear power is very difficult to spike up and down, right? You cannot just spike nuclear power up and down. That's why a lot of people call nuclear power baseload. It's the same thing with AWS. If you're an enterprise company and you sign a 5-year contract with AWS and you say, I want this much compute, you are paying for that compute whether you use it or you do not. So it can be very cost efficient to sign a long-term contract for some base level amount of compute with a centralized cloud provider. But then when you have demand spikes, something like io.net for on demand, when let's say I want to run an experiment today, or I know that my load is going to spike for 7 days or for a month, you can buy that extra capacity from io.net much more cost effectively, right? Because a decentralized network does not require contracts, does not require KYC. You can purchase varying size of customizable capacity from all sorts of different sources. And then when you're done, right? And so it gives enterprises a lot of different options and gives people a lot of choice and pricing power.
What are your target users on io.net? Let's start from the supply side, because it's super ideal for anyone like even for myself, right? I have a 4090 to supply my graphic card to io.net, but chances are my internet is not as good as the enterprise levels, and if I have to use it, I probably won't. I have to log off to io.net. But on the other side, the enterprise levels, they're kind of the more kind of ideal on that side, but it's not as decentralized as a deep end. So what is it like on that side?
Our ideal supplier is two types of people. One is enterprise data centers that have leftover capacity, right? Because that's high grade, SOC 2 compliant, 10 gigabyte up down speed, really good for enterprise customers. The second are people who fit into that bucket of a crypto miner. It's someone who is buying a dedicated rig to provide capacity or to run a GPU, either for crypto mining or for something like this. And they will typically have above average connection speed, even if it's not enterprise level, and they will have dedicated hardware that they're not using to watch movies and play video games and things like that, right?
Yeah.
Because your capacity on the GPU as well as your internet speed are going to determine how much you can provide and how reliable it is. The reason why we kind of talk about this crypto miner bucket is because GPUs are kind of like houses, right? You invest in a house so you can rent the house so you can make money, right? It's an asset. GPUs are the same. Over time, GPUs are kind of expected to depreciate, right? Because newer chips come out. What we've seen is that because the shortage is so great, the price of an A100 on the aftermarket is actually more expensive than from the manufacturer. So the price has been appreciating. The second is that most GPUs actually yield quite a bit of money when they're hired for compute purposes. Right now, you can buy an A100. And if you were to fully hire it out throughout the year, right now, io.net A100s are 99% hired. You are paying back your CapEx in 9 months because it's that much in demand. And so if you think about a revenue generating asset, right? An ROI or payback period of 9 months is pretty dang good, right? You can either buy a house or you can buy a GPU. And I know a lot of people at Web3 look at that and they go, well, that's not that great. okay, like maybe don't compare it to a crypto asset, but in terms of a commodity that you can own, right? A 9 month payback is incredible. And most miners actually look for a 1.5 year payback. And so compared to crypto mining, the economics are a lot better today just because the AI demand is so great.
And that doesn't include the any tokens, does it?
That does not include any tokens. That
Right.
is just
That's
stable
crazy.
coins that you would earn, right? Real revenue. Yeah. And then you add the crypto economics of a token on top, and it's highly incentivized, right? Because now you're getting a little bit of like validator economics where you're mining or earning a token, right? That has variable value. And you're also earning revenue from the customers. That's why, this is a little bit off topic, but we will look back in 6 months and we will realize that a compute DPIN is probably the most effective way to bootstrap a blockchain. It fixes all of the issues that traditional validator bootstrapping and validator economics has, where it's just token inflation. Because as soon as you could bring in reliable revenue to incentivize node operators, your node set grows a lot faster and the hardware specs are going to be higher.
Yeah, that was the part I want to jump at a little bit later. So, but that's the way you construct block and for the future IONET chain is based on how much actual work you've done.
I mean, there's a lot of opportunity here, right? We've been talking about once you have a large enough decentralized network, what do you do with it? There's always going to be cards that are not AI, ML ready, right? Maybe the connection speed isn't strong enough. Maybe they just don't get hired enough. So the unit economics don't work all the time. There's a huge opportunity for these devices to still be relatively high-end validators. These devices can still perform other work, right? There's other lower tier computational work that these things can provide. The reason why we started with AI and ML is because the unit economics are very strong, right? We're trying to tackle the hardest problem first and then generalize the compute network from there. The and the opportunity to build a chain, right? It doesn't have to be our own chain. Maybe the SVM decides to offer app chains. Maybe all of these validators just support Solana, right? There's a lot of opportunity, and in every single case, turning a portion of the node set into validators will provide IO with significantly more utility, right? And certainly if we end up building something like an app chain that settles to Solana, I mean, that would be super incredible because you have both a blockchain and you have a compute layer that can provide decentralized infrastructure for a dApp and make them truly decentralized.
What about let's talk about the demand side of the IONET. What kind of users are using IONET now?
Today, it's end-to-end AI ML workloads. So most people think that model training is the most intensive. And intensive is a subjective word, right? But model training today requires co-located GPUs, but you don't have as much latency requirements, right? It does not need to be like live inferenced. And so you can get away with scaling up architecture, training a model, and just having it take longer. Like that's okay, right? So there's a lot of model training and model tuning, which is a really fantastic use case because when you're training a model, all you really care about is cost, right? It's sort of a function of time and cost. Then you have inferencing. Inferencing is also very expensive. It scales very quickly and the loads are very unpredictable. And so IO.NET is really good for handling scaled up inference loads, which is you have the ChatGPT model. Now you release the product to consumers and now consumers use it whenever they want. So there's all this unpredictable load that you need to account for, right? IO.NET is very flexible. And so accounting for that inference load is cheaper. With an on-demand platform like IO.NET. And you can even fragment your compute base, right? To say base load on a centralized cloud provider, IO.NET to absorb the ups and downs. Then when you look at the long tail, right? The cards that are a little bit weaker, again, there's a lot of opportunities to run validators on the network. There's a lot of opportunities to run infrastructure for other blockchains, right? Think about ZK provers and think about sequencers, right? These are all things that could run on a compute network like ours that with slightly lower end hardware. And then you have everything in between. You have asynchronous game, cloud streaming and pixel streaming that requires more enterprise side of the network. You have things like rendering images, right? That might be on the lower end side of the network. We are, again, starting with the end-to-end AI workloads because that is a good software moat for us. It's also a good architecture moat because we can scale up a lot more than other DPINs today. And so that gives us the ability to kind of monetize this audience that no one else can. But eventually, IO.net not only wants to be an AI compute layer, but the largest decentralized generalized compute layer. And so we'll expand the customer base over time.
Yeah, correct me if I'm wrong based on my limited AI knowledge. So there are two basic type of compute that you need for for example, like ChatGPT to work. So one is you have to be able to train the model, right? And the other one is you have to respond to the input and have the output correctly and in a timely manner. So what you just mentioned is currently on IONet, most users are using it to train their AI models instead of using it to
It's
respond.
actually both. It's training and inferencing. We have a lot of both. The training is actually more of a minority because not many people today are training their own models. I think the industry is rapidly moving towards models as a service, and there's a lot of tuning. So you'll kind of get a generalized LLM, you'll tune it for your use case, right? And then you will inference off of that as opposed to training a base model. That's where I think where the industry is going because it's so expensive to train your base model. So we do a lot of tuning, we do a little bit of training, and we do a lot of inferencing.
Got it.
The platform itself is focused on inferencing because that's where a lot of the monetization I think will be for the last mile developers. And if you look at the platform, we actually built a platform product called BC8.ai, which originally was just a Gen AI demo, right, to show you how inferencing would work on the network. But now it's really popular. I think we're doing like, I don't know, 25,000 transactions a day where people are using BC8 on the network. And all of that is inferences. So you can view all the inferences in real time.
Which part of that has a bigger market share or is more costly for AI?
I think if you look at total cost to date today, training models in terms of absolute value are more expensive because you have Facebook and Apple and Microsoft. All these guys spent millions and millions and millions of dollars to train their models. But as the base models develop, the industry should swing into inferencing being the vast majority of the cost because
Got it.
more developers will come in and they will be spending money inferencing. And that's what a lot of these big tech companies want, right? They want to own a proprietary model and then license you the opportunity to inference off of it or to tune it slightly for your own use case. And then they can basically make licensing revenue forever, right?
So the training is like a fixed cost, right, for a model, and the inferences are the continuous
Yes,
cost that keep happening every time you kind of pull the model out.
that's right. That's a really great way of thinking about it.
Got it, got it. Um, nice. So what do you think about the scalabilities of LNet? You guys are on Solana. I'm just wondering, from a crypto blockchain perspective, is there any reason for choosing Solana other than other blockchains? And how does, it being a chain or SVM kind of, fit into the growth of IONET?
Yeah, we chose Solana because it's fast and cheap, right? We expect, I mean, we already have millions of transactions, and you can see during peak inference periods, like for example, for our product, when BCA gets really busy, the transactions stack up really, really fast, right? And I know that blockchain itself is still pretty early. There's still a lot of scalability questions. Even Solana itself, right, in the last few days has had some issues with transactions going through. But if you think about something like Ethereum versus Solana, right? We cannot afford to have every inference be a Ethereum transaction. It's too expensive. It's a little bit slow. Um, I think we want to continue exploring different blockchain technologies and partners, but we're going to try to keep as much of our core infra on Solana as possible. It's fast, it's cheap, it's proven that it can scale, right? At least even to this degree. And there's a lot of updates that are happening with Firedancer that I think will be really good for us to hit that next portion of scale as well. And when you think about a DPIN, right, versus a blockchain, there's definitely an overlap, right? We sort of overlap on the transaction piece, but we also have a lot to figure out in terms of scaling, right? When we take a lot of load or when we have our infrastructure scale up, like when we have tens of thousands of nodes joining in a week, we have the same challenges, right? Like how do you provide service and scale to all these different users on the supply and demand side? Very similar to Solana. And the SVM so far has just been very resilient to our use case.
Which part of the IONET is like blockchain related?
Yeah. So management of permissionless transactions between demand and supply is on chain, right? We basically allow you to join the network in a permissionless fashion. There's no intermediary, like no human intermediary on the matching of supply and demand. And so if you cluster and you pay, right, you know that the people will receive the money and that they will provide you the compute. And so there's actually a proof where the supply is committing capacity for a certain amount of time. You rent for an hour. I say I'll provide it to you for an hour. If I don't actually commit and provide capacity for an hour, I get slashed, right? The economics and the mechanisms are very similar to validators in that way.
Got
The
it.
second is that we also store proof of compute on chain. So if you look at a given inference, you can always track down exactly which node provided that compute, how much compute it provided, how much it was paid when it provided that inference, and provides a running log, right, for where the inference came from. And today it's more of a ledger, right? It's fun. But in the future, this kind of transparency and data storage will be really helpful to basically track down where some of these things are being produced, right? You might look at an image and you can always track down exactly who inferenced it, who provided the compute, and which model it was inferenced from. And I think as the AI industry develops, like this type of transparency is going to be really important.
Like how are the buyers choosing which kind of cluster they are whether they want to run the model or train the model on? Is there like a how does the matching work? Because I find that quite fascinating. Is it like I don't know, is it like Airbnb? Like you choose like you have all these stats and then you look at I like this kind of cluster and you also mentioned you kind of combine different clusters, right? Like if I have a 4090s, they have 20 4090s. Are the buyers trying to buy 21 because they need 21 going to be included? And how does that matching work?
It's a little bit of education, a little bit of market dynamics, right? I think today people don't dig into a lot of the details as much as they should. They basically say, I want this type of device. I'm looking for this connection speed. I'm looking for these locations, right? That tends to give buyers all the information that they need, and they have the amount of GPUs they need based on the capacity they're looking for. We think that as the industry develops, right, and latency and capacity are not the only driving forces, people may choose to look in certain locations for other reasons. They may choose to look at lower end devices or higher end devices based off of the economics. Today, because it's so scarce, right? Because like if you need capacity, you will take whatever capacity you can get that can serve your use case. People will look at our network and go, "Oh wow, there's 10 A100s that I can rent. They'll just rent it." Right? Or I need this much capacity. Can I get it from the 4090s? Are there enough 4090s that meet my speed requirements? Right? And then they'll just cluster it. I think that the demand side of this industry is still developing, and it'll be one of the things that I think will continue to people will continue to learn, right, as a decentralized cloud provider gets bigger.
So now it's like kind of like you're choosing to, it's like a staking mechanism, is it? Like there's different brands, right? Different names for different cluster of different providers. It's not like anonymous, right? It's not like it's matching on
Yeah, that's a good way of thinking about it. Every node has a reputation score, and
right?
so you can see, right, how often that node remains available, what its uptime is, and you can make decisions based off of these metrics as well.
Got it, got it. Yeah, that totally makes sense. Because I was kind of worrying that once you have a token airdrop or any kind of farming program, the individuals were, the ones who aren't associated with, the demand are kind of like vulnerable to kind of this like wash training or wash trading any this kind of behaviors. So
You get a lot, you worry about low quality nodes, right?
that's
That's
good.
why uptime scores and reputation scores are really important because people who add their devices in to farm, we just ping every node, right? And if your node is not responding, then you're not available. And if you're not available, you're not getting rewards. And so the crypto economic incentives are really easy here, right? Basically, if the node is available, then the demand has better service. And if the demand has better service, the node gets hired more often. If the node is more available, it gets rewards. If the node gets hired, it gets even more rewards, right? And as long as the nodes provide availability and performance when they're hired, then the demand side gets what they want because the need for compute is so great. And so everyone wins when everyone wins.
Yep. it requires more than just having a computer ready. It's more like a full-time job that you have to like keep track of it and make sure you're providing the service as promised.
Yeah, I think it's very similar to operating a miner, right?
Mhm.
Like it has the same amount of attention, has the same amount of sophistication. That's why that's sort of a sweet spot for a network like this.
Got it, got it. Yeah. Where do you see IONET in the next 5 years? Like how will your go-to-market strategy look like, and what kind of demand that you think will use? I know you mentioned a little bit earlier, and also you mentioned about coming with your own chains. What kind of your vision for the next 5 years or in the long term?
Yeah, yeah. So, we launch on 4/28, right? So we're still pre-launch. We're about 5 weeks away, and I'm sure the world will change after that, depending on how it goes. But we envision building an ecosystem of products and services on top of compute as a accessible commodity, right? If you create a tokenized way to basically allow people to get exposure to compute, then they can build a lot of things, right? Today, we know compute is very valuable, but outside of buying GPUs, you as a consumer, right, cannot really get exposure or to use it as an asset in the same way that you could with other things. So I think that our goal is to build IO into compute as a currency, right? If compute is digital oil, then it needs a petrodollar. And we're trying to build that petrodollar, which allows a bunch of different things to happen, right? We've already created a marketplace for it so people can transact. And now that people can derive value from that asset, you can imagine like DeFi products get built on top of it. As you go into generalized compute, even more things can happen because more industries can be involved. But the way that we see it is we need to 10x the supply side. We need to improve the demand side self-service customer experience, and we need to expand the use cases, right? Move into more synchronous cloud gaming use cases, look at image rendering, look at video rendering, all these things that maybe don't sit under traditional AI workloads. And that allows the market to expand on both sides, right? Because you can support lower end cards for lower end use cases, and you can support all these different customer types, right, to improve your market share. Right now, we're doing about $7,000 or $8,000 a day in top line revenue, which is annualized about $2-3 million. Again, we're 4 months in, right? And so we just need to continue to grow both sides of the marketplace and let those network effects spin. And I hope that one day, in the next 4 or 5 years, right, the platform gets really, really big. We're moving a lot of compute capacity through the network, and our goal is to progressively transition the DPIN, right, the DPIN to the community. The DPIN should always be decentralized asset. The different apps built on top of it, whether it's IO.net or other protocols and services, right, that are powered by the DPIN, those are totally separate. But progressive decentralization of the DPIN is super important to us as a resource.
I think there's probably some confusion around like how IONET look today than how you mentioned like what it is in the future. Like today, how I log into the website, if I want to like provide my GPU, I feel like it's more like a front end for render and Filecoin. It's a very niche, very nice UI for people who don't know how to mine. They can use our own computer to kind of mine those coins.
Yeah,
With that, what's the relationship for between IONET and render and Filecoin? And when you mention the future, is IONET kind of like going to provide something similar to what they're doing and potentially kind of replace them? Or how does that fit in? Just a little bit of
that's a great question. And I do have to run after this question, but I'll answer this one. So IO.net does two things. One, yes, there is a UI, right? So I think there's a user experience that makes things a little bit easier, and that's helpful. But most importantly is that IO.net provides two things to other DPINs. We provide network architecture, and we provide orchestration or software, right? Which is basically the client that runs on the device. So network architecture is important because not everyone has the ability to cluster thousands of geo-distributed GPUs into a cluster, right? So if your DPIN does not have that ability, then putting your GPUs on our DPIN allows you to basically access that set of use cases that requires that scale, right? Which is basically AI. The second is that hardware is just hardware, right? The GPUs are just GPUs. And if you want to serve AI workloads, your client, right, on your hardware needs to also be able to serve that workload in the same way that a validator, right, is a piece of hardware, and you need, a client on it to control what it does. Render is fantastic at rendering images, right? That's what that network was built and tooled to do. Filecoin was built for storage. And so these companies are very, very good at what they do. We're very good at serving AI workloads, right? Our network is not very good at providing storage, but we did AI workloads first because, again, the unit economics are really good. And so other DPINs can access our network and our tooling to basically monetize those customers. And that's why they do it today.
Got it. So AI is purely on AONet, and if someone wants to leverage their computing power to supply a Filecoin or any other like render or any other future projects, they're also free to do so using AONet as a platform.
That's right. That's right.
Got it. Got it. Super interesting. How do you think AONet will compete with other platforms that you foresee in the future? Like you guys see the monster race, and I'm also pretty sure that there are a lot of kind of similar platforms are coming out, and you have the existing ones that like a cash. Could you go a bit deeper into like what kind of modes AONet has?
Yeah. Yeah. Obviously, I think the unit economics for compute are so good that there's going to be a lot of people that try to tackle it, right? The nice thing about building marketplace businesses is that you almost always have first mover advantage. The larger marketplaces tend to have the most lasting power, even when other people compete, right? If you were to try to build Uber today and compete against Uber and Lyft, it would cost you an order of magnitude greater to launch the company because basically there's inertia, right? Like network effects and flywheels have a lot of inertia, and your user acquisition costs start to rise if you try to pull people off of the network, because you basically have to incentivize them more than their existing incentivized, and you have to overcome the friction, right? The inertia. So the way that we think about it is we're here, we're early, we're big, and we actually have a 4-year head start, right? Because Ahmad was building the network before it was a Web3 DPIN. But the network architecture, like our ability to say, do what we did today, like deploy a cluster with 6,000 plus nodes that are completely geo distributed, no one else can do that, right? It's not easy. This node is going to have like lower latency than a lot of more sort of practical node sizes, or cluster sizes, I should say. Like this cluster will be a little bit slower. But the fact that we can even do that and deploy something on it is very, very novel, right? Akash is good at what they do, right? But the reality is they have 151 nodes on their network, 119 deployers. We have 95,000 nodes, and I think like 12 or 13,000 deployers, right? So there are some big deployers in the network, but that's still a very healthy decentralization coefficient, right? Because you have a lot of distributed providers. And I would say Akash is probably one of the providers that are like, from a technology perspective, right, closer to us than others, right? They actually can run end-to-end AI workloads. They have a hard time scaling that because they can only co-locate their clusters. But listen, like you put 8 A100s in a cluster, like you can run some really healthy stuff, including Grok, right? Eight to 10 A100s in a cluster is 300 to 400 and change VRAM. And so, that's pretty healthy, right? But what we're really thinking about is how do you like super scale beyond that, right? How do you create like AWS competitive clusters that could mirror like a data center's worth of exaflops, right, of capacity? In the very long term, right, when you take a step back and think about the larger business, you also have like AI as a service businesses. So like you have Tao, right, where they're basically building like an app store for AI, and you can like kind of piece things together and like go to market a little bit faster. My perspective is that it's easier to build the compute base layer and then build the marketplace that sits on top of it than to build the marketplace and then build the compute layer. The compute layer is a really expensive thing to have. It's infrastructure, right? And I don't know, I may be wrong, right? But our approach is sort of, if we build and own the base layer, or build and like have the base layer available, it's easier for us to build everything on top of it, right? And also the beauty of a marketplace business, and you'll sort of see like today, NVIDIA announced Blackwell, Grok with a Q, which is very confusing, but Grok with a Q launched their LPU. And basically the hardware is just getting better, right? And a lot of people were DMing me and saying, hey, like, how does this impact your business model, right? You guys have a lot of retail cards. What does this mean for retail cards? The truth is that marketplaces don't care, right? It's just like Uber. When cars get cheaper, there actually becomes more cars on Uber because your average person can afford the capital expenditure to put, to buy the piece of hardware to participate in the marketplace, right? So what I expect is like as technology gets better, your highest end participants will have access to the best, and then all of the like almost highest tier will flow into like the marketplace, and then we can actually serve mid market and long tail and all those kinds of things. The last thing, I know I talk a lot, but the last thing is one of the bullish theses of IO.net hasn't really come to play yet, right? As soon as a nation state tries to censor inferences and models, a DPIN is going to be 10x more valuable. There is a data center that is on some island in the middle of the ocean that is completely out of any national jurisdiction. It's unsanctionable. The data center has its own army, and the compute hours for this data center are so expensive. It's like 100x the price of any data, like comparable data that you would compute that you would get. And it's valuable because it's uncensorable, right? It's geographically uncensorable because it's in the middle of an island. What if you could achieve a very similar uncensorable state through a decentralized network, right? That's super valuable. What happens when hardware gets very, very good, but it's all bought by US, China, Japan, Korea, right? Is AWS going to build out their infrastructure in Cambodia? Does that mean that Cambodia should not have access to AI and innovation and compute? Right? I think oftentimes, yes, the US is a big market. Yes, China is a big market. So is the rest of the world, right? Combined. And a lot of the countries this last, let's call it the last 3 decades that have really started to grow during like a more digital world, they were able to compete because they didn't have to build out infrastructure. And the more decentralized infrastructure that exists, the less these developing countries need to go through that period of like forced infrastructure development, and they can just leapfrog, right? You just jump right into adopting infrastructure and innovating on the software side. So the end game, you can probably tell based on my rambling, is a little unclear, right? But I think that our approach, which is light, software heavy, really strong network effects, really strong momentum, and really strong flywheels with a lot of optionality, I think we're going to have the ability to maneuver in the future.
Yeah, it's interesting on the unsanctionable thesis part. So obviously we have this like China sanction on the most powerful chips imposed by the US government.
Mhm.
Is it like a huge tailwind for you guys? So like, hey, these Chinese companies can now have these compute powers via renting on LNet, right? Or is it could be a headwind because there are regulatory pressures from the government?
It's pretty tricky. Look, we don't necessarily want to go and fight the regulatory fight with regulators today, right? We do things to adhere to local rules and regulations. It's not so much of the hardware that I think is the problem, right? Because hardware will always be manufactured, right? And Moore's law is very real. Even if China has a stranglehold on manufacturing and production, right, there will be other means of production because the demand is so great and the unit economics are so good. I think what's probably more interesting and maybe concerning is like censorship of data, right? Like, what if someone develops a model that is just super powerful and the US doesn't allow external countries to inference it? What if that's developed in a country that's not the US, right? What do we do then? And again, I don't I'm not educated enough to like really speak to the geopolitics of it. All I know is that for me personally, right, there's this trend of us as a world becoming more deglobalized, more insular, even though we're more connected than ever. And forcing like segmentation into our economies, right, into our global economies, that there's a lot of inefficiency there, and that's stifling innovation, right? Because you're basically, it becomes winner takes all, resources get funneled into the countries with the most money, all the countries that cannot afford to like access information and data, you basically force them back 10 years, right? Because you basically force them to develop a lot of this infrastructure, data, et cetera, in isolation, even though the answers or the base like foundation already exists somewhere else. Like they can't borrow that to innovate faster. So, you know, maybe at a country level, you have certain winners and losers, but I think as a globe, right, like innovation loses. Um, that I think that alone, I think makes something like IO.net and decentralized cloud infrastructure worth thinking about.
Yeah, yeah. This seems like a huge, like, bigger question. Let's like jump back to the IONet itself. Coming back to what we're mentioning, the first mover advantages, right? Um, so correct me if I'm wrong. Is this kind of technology sort of like not um, as special, or is like hard to copy past that as something that we see another for other products, and you kind of the one is more on like how much compute power this platform can attract, because I was thinking about the bandwidth, the scalability and the reliability of the platform. Is any like technical mods that persist on over there?
Yeah, think about DPINs a lot like layer ones, right? There's a lot of open source code. There's a lot of forking that happens, right? Most of the innovation is on the margin, right? A lot of the L1s are very similar. Maybe they differ on their consensus mechanism. Maybe they differ on their data, like data layer, right? Maybe they differ on how they read write data, like the storage layer. I think what we will find is that when you look at DeepIn architecture, the general approach is not terribly different, right? Everyone is trying to aggregate GPUs. Ideally, you can aggregate GPUs that don't have to physically be in the same location. That's like one leap, right, of network capability and scale. The second is how many GPUs can you cluster together? And as you cluster them bigger and bigger, do they all have to be the same model? Can they be different models? What is the distance between them? How much latency? Like what's your latency curve as you increase the number of nodes in a cluster, right? Now, that might sound very simple, but whether or not you can achieve that and what trade-offs you make in your network is everything, right? If someone tried to copy our approach, right, fork Ray, provide Ray clusters, but they were unable to achieve the same latency mitigation as us, when you're talking about commodities, right, which compute is a commodity at the end of the day, people are competing on like very small differences in latency, very small differences in availability and in internet connection speed. And so um, it's a bit of a non-answer, but to make it really easy, yes, there's a tech moat, right? There very much is a tech moat. There very much is a network architecture moat, as well as like how you build out the orchestration layer. There's a tech moat in the sense of, is it easy for developers to deploy? Is it easy for your workers to connect, right? Like all sorts of UI, UX decisions, orchestration decisions. There's a tech moat in how you go to market, right? Do you start with image rendering or video rendering? Do you start with storage? Do you start with AI and ML workloads? Do you start with synchronous cloud gaming workloads? Do you start with pixel streaming, right? These are all not traditional tech moats in the sense that I know how to do something that you don't, but they're very tangible decisions that someone has to make, right? If you want to develop and go to market here, you have to sacrifice something here because no one has the resources to do it all. And so, um, yeah, there are many tech moats. Otherwise, I think you would look at the networks that are available today and they would look much more similar.
So for the audiences who are really bullish after listening to this podcast, what are the ways that they can participate today?
Yeah. If you have a consumer device at home, right? You have a MacBook, you have a 4090, a gaming PC, I encourage you to connect to the network and provide capacity and just try to get a feel for like what it's like, right? We talked about it today. Like consumer devices are probably not ultimately going to be the bedrock of AI and ML workloads, right? But it's good to understand how DePINs work because again, as a generalized compute network expands beyond AI workloads, things like running validators, things like rendering images, things like any sort of like computation that is on that lower long tail, those can use consumer GPUs and CPUs, right? And it's good to just generally understand how decentralized physical infrastructure networks work because they exist to optimize, right, inefficiencies in the world. So definitely participate. If you run a miner, definitely participate. If you're really interested in thinking about investing in GPUs as an asset to earn yield, there's a lot of different ways that you can actually buy capacity in data centers, right? Invest in the hardware, pay a little bit of extra for the operating costs, and then earn yield. You know, a lot of people want to buy houses, but GPUs are yield bearing assets, right? Better than buying a car. So, think about that. That's not investment advice, but just think about that, right? Of all the things you could spend money
Yeah,
on, you can
that's a
make
novel
money.
idea.
Yeah, you could buy a car, you could buy a house, or you could buy GPUs, right? There are people out here who are buying thousands of like NVIDIA 4090s because they're getting cheaper and they're running compute workloads on it, right? And seriously, like these things pay back in like a year and a half. Again, not financial advice, but like how many yield bearing or revenue generating assets can a regular person own that pays back that quickly, right? So it's an interesting thought, right? It's just sort of like a thing that you might invest in that you don't really think about. Um, you know, Keep an eye on how the ecosystem develops, right? We're basically financializing compute. If you believe that compute is digital oil, what we're trying to make IO is we want to turn IO into like the digital petrodollar, right? Like if compute is oil, like digital oil, then we want IO to feel like the petrodollar, where an entire ecosystem of financialized products, tools, and services, like a whole DeFi ecosystem, can be built on top of IO, right? And then, if you're a developer, play around, right? Deploying a cluster, like I deployed the cluster today. It took me, I don't know, like 3 minutes to deploy 6,000 nodes. And I'm going to spend the rest of my evening seeing if I can run Grok and some other stuff on it, right? I'm only going to have it for 12 hours, but as a regular person, how often can you get access to that amount of computing power, right? Even if it's for 10 hours. I mean, this is pretty expensive. It's like 20K, maybe do like a smaller version of that. But as a regular person at home to be able to deploy that much computing power against anything is like very, very novel and interesting, right? And yeah, generally speaking, even if you don't want to provide compute, even if, um, you just want to be an observer and learn and be educated, I think there's a lot of really healthy discussion that's being had in our community around things like availability of data, right? Preservation of censorship resistance AI models and inferencing. And like, for me at least, right? That's a very big part of why I do this is like, yes, there's this really amazing business from a revenue perspective that can be built, but it also has an opportunity to be a little bit more impactful than just that, right? Um, and so, we have some really smart, really great thinkers in our Discord who are sitting around talking about this stuff, and I encourage people to just jump in and have a conversation.
Awesome. Thank you so much for coming on. Garrison, is there any final message?
No, thank you guys so much for having me. I follow WuBlockchain. You guys are always like one of my favorite like Twitter outlets. And so I really appreciate you guys for doing this.
Appreciate it. And yeah, for the people who want to know the update on, your deployment of Grok, what's the best way to find you?
I'm going to be live tweeting it from my Twitter, 0x Hushky, Hushky. I'll also probably be live tweeting it from the io.net Twitter as well. And yeah, follow us on Twitter, jump in Discord. We'll be around.
Awesome. Thank you.
All right. Thanks, man.